The scientific method, I will be doing an ice melting experiment. Observation and question. In the winter, when ice covers roads, people put salt on the roads and the ice melts faster than the ice that is untouched. That is my observation, and my question is, why does adding salt to the water change how fast the ice melts compared to plain water? My hypothesis and prediction. Hypothesis, since road salt melts ice in the winter, then an ice cube will melt faster in salt water. Prediction, when in equal amounts of water and ice, the ice in the water with salt will melt first. These are my materials for the experiment. I will be using 2 identical cups, a measuring spoon, which will be half a teaspoon. I will be using a measuring cup, which will be half a cup. Stopwatch, I'll be using my iPad as the stopwatch. Thermometer, salt, and ice cubes. Variables and control. My independent variable will be the amount of salt in water. Dependent variable will be time in which ice will fully melt. The control group will be the plain water. And controlled will be the cup type, the amount of water, amount of ice cubes, same room conditions, and same timing method. This will all be the same. Now I'll be setting up my experiment. I'm going to be using half a cup of water in each cup. There I am, just pouring it into each cup. And they will be the same room temperature. I'm just getting it out of the tap. Okay, there we go, proving that it's even. Now I'm going to be putting in some salt. I'm going to be doing half a teaspoon of salt each time. It's going to be a level scoop. Just one, and that's going to be my independent variable. So I'm just stirring it in, making sure that it's fully dissolved. Okay, now that it's fully dissolved, we are going to label them and take the temperature, which at that time it looks like it was 79 degrees. It's going to be the first trial. Now we'll be taking the temperature on each cup, each trial. Just, because the room temperature can differ depending on the time of the day. So so that might change a little bit. But yes, so now we're going to move on to trial 1. Now we are ready to start the experiment. Here I am dropping the ice. And I started the timer already. Okay, so now we're just going to go ahead and wait to see which one melts first. And I did speed up the clips just for time. As you can see, the plain water is melting faster. There I am showing that the ice is still in there. You can kind of see it, but just because of the angle, can't see it fully. Okay, now I'm showing that the ice is there. It's almost gone. Okay, The ice in the plain water melted at 6 minutes and 41 seconds. Now we just have the saltwater ice. There's still ice in the water. There's just a little bit more. Here I am showing the shape of the ice. It was a narrow, long shape. It did look different from the ice in the plain water. And I moved it with a stick just to make sure that it was not just the salt. I wanted to make sure that I was actually seeing the ice. And there we go, trial 1 is complete. And there's the screenshot of the time. Now we're ready to start trial 2. Here I am just filling the 2 cups again. It's half a cup of water for each and 1/2 teaspoon for 1 cup. And the temperature for this one was 72 degrees Fahrenheit. Okay, now I'm getting ready to put in the ice. 2 evenly sized ice cubes. Now we just wait to see which one melts first. So you can see that the plain water, it's melting the ice a lot faster, like previously. It does seem to have a lot more movement in the cup as opposed to the saltwater one. There I'm just pointing that to show where the ice is because it is kind of hard to see once it gets small. Okay, so the time for that was for the plain water ice, it melted at 7.4 minutes, but I did click stop accidentally, so it shows up at 7.5 in the screenshot later on, but it is 7.4. That's the correct time. And it does get a little bit hard to see the ice in the salt water because it does start to turn more of a clear color towards the end. It's like a cloudy clear color and it melts into like a longer shape. There I am zooming in to make sure that we can see the ice. It's on the upper um, on the upper right hand side of the cup. And I did move the ice a little bit just to make sure that I was actually able to see the ice. I didn't stir, not to not make it melt faster, but I could not see the ice and I wanted to make sure that it was still there. You can kind of see it in there. Okay, and then that concludes the trial number 2. There I'm just showing that the ice is fully melted, and that's the correct time for the plain water, 7.4, and the time for the salt water was 18.55. Okay, now we're ready to start our third and final trial. here I am just setting up the experiment once again with the half a cup of water. There we go, it's even. And now I'm taking the temperature, and this time it is different, so it's 70 degrees Fahrenheit. And then I'm adding the salt. Okay, and there we go, salt water and plain water. Now we are getting ready to put in our ice. Okay, and now we're going to start the timer. So now I'm just waiting for the ice to melt again, and like previously, I do see that the plain water ice is melting a lot faster, and there does seem to be more movement in the plain water cup. Um, Seems to be more movement than the saltwater one. And I did point earlier because the ice seemed like it was close to being around the same size. So now there's just a little tiny bit of ice left in the plain water. Okay, so the water melted. The plain water melted at 8 minutes and 8 seconds. I accidentally clicked it twice, but it was 8 minutes and 8 seconds. Now, now we just have the saltwater ice left. It is kind of hard to see, because I did observe that the ice in the salt water, it was turning more of like crystalline, like it was like more clear, compared to the one in the plain water, which was a little more white looking. So it's kind of hard to see in the salt water, but there's still some ice in there. There we go. I was just pointing at it. You can kind of see it when I point at it and zoom in, but it's a little bit hard to see on camera. And there we go. That was the third trial. And there's the screenshot. Here are my results and averages. I ran 3 trials with identical volumes and cubes. So each of the starting temperatures was the same for both cups. Here you can see that it was 79 degrees Fahrenheit. First trial, second trial was 72 degrees Fahrenheit, and the third one was 70 degrees Fahrenheit for both cups. Okay, and the melting times for the first trial was, for the plain water in the first trial was 6.41 minutes, second trial 7.4 minutes, third trial 8.8 minutes. So that averages all out to about, it averages out to 7.18 for the plain water. Okay, and then for the salt water, the times were first trial 17.48 minutes, second trial 18.55 minutes, third trial 17.17 minutes. So that averages out to 1773. And so that means that the salt water took about 10.55 minutes longer to melt, which is roughly 2.47 times longer. And I did observe that the salt cup it turned slightly cloudy as it melted, and the ice melted in a more elongated shape as opposed to the plain water that melted in a more round shape. The plain water cup it stayed overall more clear, and the ice had more movement inside the cup throughout. Overall, the the results do contradict my original hypothesis that that salt would melt the ice faster. Analysis and conclusion. So did my results match my prediction? No, my results did not match my prediction. I predicted that the salt would melt the ice faster, but that did not happen. Now, why? After doing some research, I've concluded that the reason road salt melts ice on the roads, but it did not melt in the ice cup faster, was because on the roads there's extra warmth from the sun and the pavement that melts the ice. It's not the salt that melts the ice. The salt just prevents it from crystallizing. So the salt the salt in the cup then acts like a jacket around the ice cube and thus keeps it colder and the ice melts slower. And what could I have done to improve this experiment? I would say more trials would have helped to get more accurate averaging time, and a frame by frame analysis of the ice cubes throughout the experiment would have improved the experiment just to see um, at what stage of melting is each cube throughout the trials. And having identical weighing ice cubes, since I did not weigh them before I put them in the cup, it could be off by a few milliliters, excuse me. Um, and then also bigger cups for a better view of the ice cube itself, because sometimes it was hard to see on video.